Tonight is November the 16th, 2019, and I'm going to continue some video here on rectifiers. The other one that I posted just recently, there seems to be quite a nice interest in it, and one good gentleman mentioned that, well, maybe I should actually adjust the bias properly each time I change the rectifier, and I got to thinking about it, and after doing a bunch of measurements, I have to completely agree with you. Thank you, sir. And that's exactly what I'm doing. Also, I've built an interesting little box right here just from a spare chassis. You can see once upon a time I had one of those little Poseidon boards in here. This was going to be something that never happened. But anyway, I've put a 5-volt transformer on it, and I've got it set up so I can use the 816s, or the 866s, the 3B22s, the 3B28s, just about everything. And what I want to compare tonight is we'll do a 5U4 and a 5R4 maybe. 5R4 it doesn't perform very well at high currents, but anyway, that one was asked about in the last video. But what I want to show you here is these 866 rectifiers are absolutely amazing. Let me show you this. Excuse me, I have to get in front of the camera here. I hope this is nice and clear and you can read this. Here's the 816 right here. Look what that thing cost back then. $1. And an 866 was $1.50. Holy cow. Okay, what it says right here is this little 816. This little bitty mercury vapor rectifier says, two 816s operating on full wave rectifier circuit are capable of delivering to the input of a choke input filter a rectified voltage of 1600 volts at 250 milliamps. It has another one up here. It says, oh yeah, right here. The RC816 is a junior transmitting type tune for the particular and medium power transmitter up to 400 watts. These little guys right here are good to 400 watts. Now the 866A is good to, it can deliver 3200 volts at 500 milliamps. That's 1600 watts. I never imagined that these little mercury vapor rectifiers were so powerful. And the voltage drop across them, if you look here again, is constant. Let's see, darn, it's always plate current, peak average, tube voltage drop approximately 15 volts. 15 volts. That's actually why if you have a TV7 type of a tube tester, they tell you to make sure you use that mercury vapor rectifier that they installed in it, and they mention that because the voltage drop across the rectifier is constant under load. So these things right here perform within an inch of as good as a solid state rectifier. Absolutely amazing. Okay, first of all, everything's all warmed up. What I do, so I don't have to turn things on and off, let it warm up too much, I've installed this octal plug right here that goes to this. All I'm taking over to here is the high voltage AC and taking the DC back. That's it. So what I do is I just unplug the rectifiers. I've done this for years and years. You can do this. I've gotten away with it all of my life. Okay, first of all, we'll set our standard by plugging in the solid state rectifier. Also, I changed out, I don't want to flip it over right now and show you, but I changed out the choke in here to that 1.5 Henry 500 milliamp. Oh boy, did that make a difference. I'm telling you, this thing's got a power supply in it now worth having. I want to show you what these two KT88s will do. First, like I say, we'll set the benchmark here with the solid state rectifiers. We'll set the input voltage always to 120. So those are the two constants. And well, and then we'll also set, if you can see this, I'll zoom in it so you'll see what I'm doing here. As close as possible, I'll set this to 75 milliamps each time. So no matter what rectifier's in there, see right now it's at, I'm trying to keep the lights off because that keeps the glare down, but I guess I got to turn on just for a second here. I don't know if that helps or not. It's set right now at 79.4. I can back it off just a little bit. I'll try to get it down to about 75. I don't want to take up a lot of time fiddling with it. Okay, there's 75. We'll settle with that. I'm going to turn the light back off. Keep the glare down. So we got 75 milliamps per tube. They are perfectly balanced. Better than a milliamp per tube. That's set with this potentiometer. This potentiometer back here sets the bias and therefore the plate or cathode current, whichever one you want to call it. And this right here is the balance between the two tubes. Okay? Now with that, we're not going to test it at a lot of frequencies, although it performs exceedingly well at its rated power 65 watts. But here's what it'll actually do. Now, let's see, we're running a kilohertz. Oh, now what am I doing wrong? Oh, gotta move this down, sorry. I'm trying to, okay, there's 42 watts. There's our power. There's our frequency. There's our THD. And, yeah, let me get, I think, yeah, you can see it all right here on the camera. Set this one here. There's the output. We're going to turn it up until it clips. Let me get underneath it. Turn it to right there. 87 watts. This thing is powerful. 87 watts at 0.5%. All the way up to clipping, or 1%. Let's set it at 1%. Right there, that's 88 watts. That's no woofing, huh? And once you get just right below clipping, the distortion goes to, see, to 0.5%. At 80, that's 85 watts. Look how clean that looks. Okay? So there we go. 85 watts. Now, what I'm going to do, I wish I didn't have to get in front of the camera, but I have to get in front of it a little bit. I'm going to unplug this one. Unplug the rectifier, the solid state rectifier. You can see everything went to 0. Numbers like this now are just random. They're meaningless. Get in front of the camera again. I'm going to plug in. Well, let's say I'll turn this back around here now. Show you what I'm doing now. See, I've unplugged this rectifier. Set it right up here. Now I'm going to plug this in, which are these little rectifiers here. I want you to be able to see them when they come on too. Yeah, watch these guys. I think they're beautiful. There they are. I think you can see that quite well. Man, aren't those things just really neat? Okay, well the filaments have been warmed up for a long, long time, so all that's good. As long as I leave this on, the filaments are on. Okay? So, what we need to do now, though, is to look back up here at the emitter. I'm not going to move the camera around again, but I'm going to make an adjustment here so that it's, oh, I can turn the volume down. I'm going to set the, oops, wrong way. I'm going to set it to 75. I don't know how much it was off, because I actually was driving it then. I do that all the time. There we go, 75, there it is, 75 milliamps. So we're back to that. Now, let's do it again. Let's turn the camera back around so that you can see everything at once. We'll run this one up to clipping. Look at that. That's before 84 watts. It's the same number for all practical purposes. Our line voltage is it's right now at 121. I do have to watch that because it does load it a little bit. If I turn it all the way up to where I get 1%, that's 85. It's the same number. The MV rectifiers work just as well And see, if I turn it down to anything 60 watts, it's 0.3% THD. What a beautiful sine wave. The MV rectifiers, if you're willing to fool with them, the darn things work just as good as solid state. They got 15 volts drop across them with, I think, within the parameters they can be run in, regardless of the load. Now, I don't know if we want to go through and do all of it with all of these tubes, but I have done it. I've brought out, see, these are 866s. The difference between the 866 and the 816s at this power level is basically nothing. Here's 3B28s. They do the same thing. Now here's an interesting tube. It's called a 3B22. It only takes one of these guys. I'll plug this one in just for fun. But this is a Xenon filled one. They're actually not rated at the voltage that we're running them at, but they, you know, vacuum tubes are pretty resilient, so they work pretty well. I have to plug two of them in because the filaments are 2.5 volts on every one of these rectifiers out here, but I put them in series and run them at 5 volts. But I've only got the plate lead internally connected to the socket on this one in the back. I'm going to unplug this one. Touch something I shouldn't be touching. You can see when I unplug it how, whoops, oh, you didn't see that, did you? I'm sorry. What's these MV rectifiers? You saw them on, so you can see how they're on and glowing that beautiful purple. When I unplug it from the amplifier, they just simply go off. So that removes the high voltage. So let's do this, and then we'll move on to the last thing that I've got something you guys are going to really like. Okay, let's take these beauties out. Isn't that neat? I mean, these little guys right here will power a 400 watt amplifier. Man, I tell you, old technology isn't all bad, is it? Okay, let's plug in a couple of these guys. Like I say, I have to plug in two of them, but I'm only running it off of one of them, as you'll see, because only one of them actually gets the high voltage on it. It doesn't, well, yeah, this one actually doesn't matter. Here's actually a matched pair of them. We got to give them just a little bit of time to warm up. And I'll flip the camera around while it's warming up, and I'll show you something here, and then we'll discuss this a little bit more afterwards. This is going to be the next project. Let's see if I'm zoomed out far enough. There we go. Not only, this is an audio. It's going to be an audio amplifier, and I've got two transformers like this, and I've made an AM transmitter before. This is part of the AM transmitter. It's going to be the modulator, which is just an amplifier. 1400 volt center tap. I don't know what's rated at, probably 400 or 500 milliamps. This guy's pretty solid. I got two VR tubes back here, some 866s here, so I'll use MV rectifiers. The VR tubes is to regulate the screen voltage. This is a pretty little thing that I just got, a regulated supply. It's got a VR tube in it right there. You can put like an OA2 or an OB2. You can regulate it at 108 volts or 150. It just plugs into an octal socket. Isn't that cool? And then I'm going to use just a Williamson circuit driver. I'm either going to drive 4 of these. These are the 1625s or the 807s, whichever you prefer to call them. And the primary impedance is 3,500 ohms. Well, generally they want about 6 or 7K, but if I put 2 of them in there, then it'll match this transformer quite well. This transformer is rated at 250 watts. As you can see here, the 8 ohm tap, for some reason, is only rated at 100 watts. But the other taps are rated at 250 watts, which will be the ones that I actually put over to the other transformer like this to turn it back around as a modulator. I don't know if that makes sense to you yet, but I'll do my very best to explain. So I got a 250 watt output transformer, something here that'll deliver 500 watts or well over. Well, anyway, that's it. That's going to be the modulator, and this I'm going to build. So it took me a long time to kind of come down out of the stratosphere that everything has to be at the kilowatt level, and that's just kind of crazy. I'll put the 500 milliamp choke in the bottom of it. This is a 4-inch chassis, so you can mount a lot of things underneath the 4-inch chassis. And I'll have to have filament transformers, for these guys and these guys. Well, I'll just have to have 2. Well, actually, no. I'll run these off the 5 volts from here. No, this has got the filament wires on it. What am I thinking? I don't need to add filament transformers. It's all right here. Just add a choke underneath, and it's going to be really pretty with these 4 right here glowing. Okay, let's turn back around to this fellow now. And we'll plug it back in. And I don't know if you can see it. Let it sit there for just a second. I'm going to take the I'm not going to take the camera off, but I do want you to see down inside this tube. See, there's only one of them on. See, this one, the filament's on, but this is the only one that's actually got the plate leads hooked to it. I only wired this one up because if I wired them both up underneath, then I'd have them parallel, and that would not be using just one of them. Okay, so this is the 3B22. Let's set this back down here gently as we can, and the plate, the cathode current didn't change. It doesn't even change. I'll show you right here. I don't like to claim things that aren't true. That's why I like to do these videos like this. So there's its plate current. Well, it's soared up from 75 to 76. Well, you know, it does wiggle around a little bit. But anyway, that's what it is. And let's see how it performs. Yeah, we're getting an enormous amount of power out of these guys now. Okay, I believe we've got it on all of the important things to watch. Let me start running it up. Just below clipping, so that we're not over 1% THC. We got 85 watts again. Pretty amazing, huh? Okay, so what have we proved? We've basically proved that the MV rectifiers, if you really want to deal with them, and these Xenon rectifiers, the 3B22, the 866, and the 816s, they work. They provide the same amount of power as a vacuum rectifier, like a 5U4. Okay, now we're going to go back to the poor little 5U4. Here's one right here, I believe. Yeah, 5U4 GB. Actually, a very nice one. I know it's in good shape. And we'll plug it in. Fortunately, they warm up real quick. And then we'll give it a second to warm up. And then we will... I'm watching the... you got to see this. This is... I don't want to call it sad, but it almost is compared to those MV rectifiers. Look what it dropped to, 36 milliamps. We got to run that back up to 75. Yeah. So the other day when I was doing this, it just wasn't fair. World. It's like it took off here or something. Something went wrong there. 102. No, we don't want that. I did that. Must be like a dirty spot on the pot or something. We gotta get back down to about 75. There we go. $75, $76, bouncing around a little bit. But for all practical purposes, we're back at the same spot. I don't want it to be below 75 because the more current you got, I want to be really fair to this 5U4. Okay, there we go, 75. Okay, and then we'll zoom back out. Go back over to our so we can watch it all, and then crank it up. Let's get this one displayed too. Bring it back up to clipping right there. Something below 1%. That's I want to get the one. I want to be as fair as I can to this poor guy. 66.8 watts. 67 watts. I mean, it's not terrible, but that's all it'll do. 67 watts. Of course, the plate voltage is much lower now. When I say much lower, about 50 to 60 volts, 40 to 60 volts, somewhere in that range. That's what we measured the last time. But you know, basically what you have to, the conclusion you have to come to is a 5U4 is good for about 80 watts. And an amplifier is about 50% efficient. These are just ballpark numbers, but there's something that you can play with, you can keep in mind in your head. And at 50% efficient, you can get the output at about 40 watts. That's really all you can hope to get out of a 5U4 and have it consistent across the range, across the power range. If I plug in a 5R4, it'll probably be just a little bit less because it's a higher voltage but lower current tube. If I plug in that 5V3, which is a higher current tube, it performs slightly better. Nothing really worth wasting our time documenting now. The 5V3, the 5U4 are the same thing for all practical purposes. 5R4, you know what I'm going on. And 5Y3 is not going to work very well at all. So that's about it. Or go to solid state. But I'll tell you, I am just really, really impressed with these guys. Now, again, I'll mention this once again. I don't know if I made myself perfectly clear. These are full wave rectifiers. Ouch, that's hot too. These are full wave rectifiers. So you only need one, like a 5U4. These guys right here, these 866s and 816s and whatever, these are half wave rectifiers. So you need two of them. It takes two of these to do the job of one of these, or one 5U4 or whatever. Now I have also a bunch of these guys right here that are just beautiful. These are called 3B24s, but the maximum plate current on those is rated at 60 milliamps. Now I know we can abuse them, but they've also got a really goofy filament configuration where you can only run half the filament. I guess that's to conserve power or something, I don't know. But they're rated at like 10,000 volts. Well, actually the MV rectifiers are too. These are rated at very high voltage but low current. Probably back in their day, I'm going to guess they were used in things like CRT display, high voltage supplies or something like that. So anyway, that's it. I wanted to be fair to the 5U4, to our beautiful vacuum tube rectifiers, but this just really got me experimenting with the MV rectifiers and these Xenon rectifiers, and they are good stuff, even though they're a technology that is pretty ancient. You know, I get asked questions sometimes on the videos about how to do this and how to do that. Well, if you want to design your own, so to speak, you just take bits and pieces of each one. Like this part right here. This is the Williamson Driver. You can duplicate this. You can look at different ones and get different schemes for balancing the cathode current. See, that's how they do it here. This is a cathode bias. It's not fixed bias. But you just look through them until, and you pick the parts and the pieces. You pick the bias scheme from one, you pick the driver scheme from the other. Here's another Williamson Design. Looks completely different, but it's the same. It's got, see, this resistor right here, this potentiometer is used to set the overall current, and this one right here is used to balance it between the sides. So if you start looking at these, you see that pretty clearly. This is a Williamson. It even says it right there. This is one of the best performing amplifiers I've ever built at 20 watts. Of course, you know I like to build things bigger than 20 watts. But there you go. That's it in a nutshell. So I'm getting some pretty amazing power out of these guys right here in this triad transformer. Quite an impressive old transformer. This is a UTC transformer. Wow. Again, the Williamson circuit, it just definitely outperformed the one that I put in there before. I use a balance right here because this one has fixed bias in it. I use a balance pot here and a pot over here to set the range. That's exactly what I'm talking about. It's not this circuit right here, but it performs the same thing. This one sets the amount and this one balances it. This one sets it and this one balances it. So there you go. I don't know what else to say about that. I'm always trying to think of something right here at the end, because after I shut it off, I then think of something else. Let's turn back around to this guy. I am actually set on this. I can start on this and get this built in a week or two, I think. But that's it right there. Big guy. That's the whole modulator. And what it will do is I can hook it to a speaker. I can hook it to 8 ohms and test it. And I should get as much as, well, probably not more than, but up to 250 watts out of it. You can actually get 120 watts per pair, so 240 watts. And then I'll use that. That'll be a self-standing modulator. I might actually have to put, I don't know if I'll have to put a preamp stage on the input. I very well may, but that'll be one more tube. I might just be able to change this to a 6SL7. And yeah, I bet that's what I'll have to do. I'll make it a Williamson type circuit, but use the 6SL7. A 6SN7 is basically the same thing as a 12AU7, and a 6SL7 is basically the same thing as a 12AX7. 6SL7 is a high mu triode, 6SN7 is a medium mu triode, so that should do the trick. Yeah, that'll work. And I can plug the microphone straight into it. Have a gain control on the front. Yeah, that'll work. And I'm just really excited about this. This was a lucky find right there, and it works. I've already taken it apart and painted the outside, you know, cleaned up some of the rust that was on it. And I've tested it. See, look how it works. You put 115 volts in here and here, and you get ground, and you get B plus and B minus out there. Isn't that? Wow. So I'll have at least 5 glowing tubes back there, VR and MV rectifiers. So stay safe, have fun with these MV rectifiers. Beautiful old technology that it's a lot of trouble, gotta have filament transformers and all that kind of stuff, but it's you can see from the measurements tonight, it actually performs just as well as the solid state stuff of today. Thanks for watching. Stay safe.